The first key to building a growth mindset is to simply understand and talk about neuroplasticity. So what that means is neuroplasticity is this idea that our brains become wired and we have neural pathways and they can be rewired according to how we use our brain. So the brain changes and grows according to how we use it. So some of you have seen in my other videos diagrams with X's and dashes to represent the neurons. So I'll do that really quickly, but I'll show you another way to show this concept of myelination and neural pathways. So these X's represent neurons, and the first time we have a thought, these neurons are sending an electrochemical pulse to each other that has to jump over a gap. And because we're in similar environments over and over again, receiving similar stimulus, we tend to have the same thoughts over and over again. And the first time we have a thought, there's a higher chance we will have that thought again because these neurons kind of know each other exist. As we keep having the same thought, the brain then considers this to be a high priority pathway, if you want to call it that, and will then coat or send white fat called myelin to cover the connection between these cells so that they don't have to jump over the gap. It goes faster through the white fat and becomes an uninterruptible signal where it's high speed, it's automatic. So we see this, for example, when a baby's learning to walk. It doesn't have the myelination yet to know how to move its leg, but after it has done it enough times, this becomes a myelinated pathway. The brain has sent the signals enough times that it becomes automatic and we don't have to use a lot of mental power and energy to think about how we move our leg each time. We need to have this in order to navigate our world. Otherwise, we would be constantly having to relearn and use so much mental processes to just navigate everything, basically. So it's a way of our brain to categorize things that we can kind of move on to the next level and more mastery and complexity. So this goes not just for walking, but even, for example, if I receive a message from home that I'm a bad kid or worthless or not going to amount to much, there's a good chance I'm going to be in a similar environment over and over and over again. I'm not probably going to change families from day to day to day. I'm going to be with the same kind of stressed out people who also learned their own messages from their childhood. And that can get passed down really quickly, as you can see, because I'm going to be in that same environment. If I hear that message enough times, eventually the brain will have had that thought enough times that that becomes now a myelinated high priority pathway. In the brain, we call it survival of the busiest. The networks that stay busy myelinate, and they're the ones that survive. So this is true. However, it is also true that we can rewire our brain because, just like I said, it's survival of the busiest, or another word we can use is use it or lose it. Cells that fire together wire together. So if we have a competing network, we can also the brain will then send energy to competing networks and can take away myelination from other ones. When we don't use it, we lose it. So that's like basically myelination and neural pathways in action. One way that you can demonstrate this to staff or students is by using markers, clickable markers, and I usually have 2 or 3 people stand up and I have them represent the neurons in the brain. And each of them send a pulse by tapping the markers together. And as they repeat a thought or a movement or a skill, eventually they click the markers together and it becomes this pathway. It's not like this in the brain because the gap is still there, it's just coded, but you can do this as a kind of tangible, concrete way to talk about myelination. So this now becomes this pathway. And what we have to also understand about the brain is that change is expensive. It requires enzymes, it requires a lot of resources. The brain is not going to devote resources for myelination unless something is happening consistently. So Bruce Perry, who does a lot of work on resilience and neuroscience, talks about patterned repetition. There needs to be a pattern of repetition of something in order for it to eventually myelinate. It cannot just happen once, just like if you were going to the gym and lifting a weight once, if you didn't come back again, there was no pattern of repetition on that, you would not build the muscle. It's the same thing in the brain. There's a lot of different theories about how long myelination takes. Some people say 66 days, some people say longer. I think it really depends on how complex these networks are, what kind of skill we're talking about. But the basic rule is that there has to be some type of patterned repetition. And often there is a certain amount of discomfort because if we are building something it is leading to new activity in the brain, which leads to different biochemistry and all of that stuff. So there's usually often a bit of struggle and kind of not wanting to do something because it's not our norm. So to myelinate, there has to be patterned repetition. So a few phrases that we can use, I mentioned it, is use it or lose it. Cells that fire together, just write those words, fire together, wire together, and survival of the busiest. So those are some sentences that you can use. Also, Stanford has used the phrase, the brain is like a muscle that grows with you. So really demonstrating that it's like a muscle and talking about it like that. So that's the first step. Talk about neuroplasticity. Understand it for yourself, and we'll see the next keys in the next videos.